Here we're going to construct a truth table to prove an argument is valid. First, let's see. This argument has two premises, P or Q or R. The second premises, negation of R. Therefore, the conclusion is P or Q. As we know, P and Q and R that represent statements. So if this is a valid argument, this will work for any kind of statement P, any statement Q, and any statement R. First, we put PQR and all the truth values for them. Now we start with the first premises. In the first premises, it has two operations. So we're going to start with what's in the parentheses, Q or R. So if one of them is true, then this statement is true. So let's look at Q column and R column. T, 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 F, T, 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 F. Now let's start work out the second disjunction. So this time we're looking at the first column and the Q or R column. Again, if one of them is true, then it is true. And now let's do the second premise, negation of R. So we look at the R column and negate the truth value. And now let's look at the conclusion, P or Q. So that's the disjunction of the first two columns. If one of them is true, then it is true. And now if we look at the two, first we look at the two premises columns. So that would be these two columns, premises, premise, and this one is also premise. And then we got a conclusion column. And we're gonna circle the true premises. We have two, so we're gonna make sure both of them are true. So these two, and these two. And we check the corresponding conclusions to make sure they have the true conclusions. And in this case, they do. So we'll say the argument is valid. In this example, we're going to prove this argument form is invalid. The first premises, if P, then Q or negation of R. Second premises, Q or Q, if Q, then P and R. Conclusion, therefore, P implies R. Now, first, let's put different combinations of the truth values of PQR in the table. First premise, the implication, if then, this is always the last step. So we start from the right side, and negation always goes before and or. So we do negation of R. So take the opposite value of truth values of R. And next we do the disjunction. So the Q column and negation of R. One of them is true, then it's true. Now we can do the implication. So this is our first premise. and find the hypothesis column that's the first one, and the conclusion here. So for the implication, first we look at the hypothesis. All these are true, so the truth values will be the same as all the conclusions. So we get T, T, F, T. Now for the rest of them are false. We will get true, 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 true. Now the second premises, again we start from the right side, P and R. So because we have to do the save the implication for the last. Now P and R, that's the first and third column. We need two truths to get a true. So true, false, true, false, 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 and false. Now we can do the implication. The hypothesis is the second column, and the conclusion is this column here. So let's check. So these two and these two are true. So let me copy the truth values of this column right here. So copy these two here, T, F, and copy these two here, F, F. And for the others, I'll just put true because the hypothesis is false. Okay, so this is another premise. Now the conclusion, P, then R. So hypothesis, the first column again, and again let's copy the first four, copy the truth values of R, and for the rest of them we get true, 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 true. Now let's circle true premises. So both are true, so we are looking at these two, both are true. This one's false, false, and these two are true. These two, and the last two. Now let's check the corresponding conclusion. Okay, so looks like we have this one that is false. So that means we have true premises, but we get a false conclusion. So that means this is an invalid argument.